Greetings, I'm your host, The2ksGamer, and today we will be talking about carbon nanotubes. Let's begin by describing, in essence, what carbon nanotubes are. Carbon nanotubes, or CNT for short, are, as the name tells, tubes at the nanometric scale made out of carbon. This is, at the base, an allotrope form of carbon, which is part of the fullerenes family, a fullerene being a molecule composed of carbon that can take multiple geometrical forms. CNT revolutionized many fields, be it scientific, construction, research, manufacturing, and many others. Let's continue with the history of its discovery. Discovery of carbon nanotubes have been, through multiple magazines and publications, wrongly attributed to Sumio Dejima, a Japanese physician. In truth, the very first true observation and discovery of CNT has thus far been revealed to be the work of Radushkevich and Lukyanovich, two Russian scientists, who had published clear images of carbon nanotubes of about 50 nanometers of diameter in their Journal of Physics and Chemistry back in 1952. Unfortunately, it was, unknown to the public due to the Academy of Science of the USSR research subjects and publishings being blocked in the United States as a result of the Cold War. It is to be noted that even though Dejima weren't the original person to discover carbon nanotubes, he still was the person who brought attention to the new wonder material, sending waves of scientists and research funding in its direction, basically opening the doors and development on the new material. Next up, the discoveries made about carbon nanotubes, and oh boy is this gonna wreck my brain. So to begin, carbon nanotubes, since they are at the nanometric scale, have shown incredible properties with further research being done in the last 60, soon to be 70 years. These include chemical, electrical, thermal, and mechanical properties. Most of these properties show that CNT has equal or superior performance and reliability than standard materials we are used to. Following the discoveries, these properties were studied more in depth using new observation technologies, like for example the electron microscope, along with electric and chemical testing by reacting it with different chemical components. On the subject of properties, let's start by talking about the properties and questions that make CNT a prized material in the modern world. First of all, carbon nanotubes exert incredible mechanical properties. This is due to the fact that CNTs are assembled on the atomic level, being perfectly structured along with the composition of the material not being the result of an alloy, like steel for example, often being an alloy of iron, carbon, and other small additives like magnesium and nickel. Instead, they are made 100% out of carbon. Comparing it to aforementioned steel, CNT is equal, if not superior to it, while being extremely light. This could considerably reduce the costs and restrictions to modern architecture and other mechanical applications. This also enables new perspectives for vehicle manufacturing, as CNT can absorb a tremendous amount of force before braking. It is also extremely resistant to many forms of mechanical abuse, like torsion, compression, stretching, and normal wearing. This is a very useful characteristic that is very valuable and sought after in many industries, as it could cut down majorly in maintenance and repair costs. Another very useful property of CNT is its chemical ones. Carbon, the one and only component of CNT, is a near completely unreactive element on its own. Extremely powerful chemical agents must be used in order to even provoke a basic reaction, which is uncommon in everyday situations, even if not all manufacturers or factories because of security measures and basic environmental issues. Also, since CNT is in essence a tube, it has a hollow structure, which lets scientists in factory insert chemical compounds like fuel, electrolytes, or even other elements to form a carbon-infused polymer, etc. For example, the Rochester Institute of Technology investigated the use of carbon's non-reactiveness and reusability for chemical removal and filtration purposes, coming to a very positive perspective for the future, effectively making a major breakthrough. Carbon nanotubes can simply suck up the chemicals and impurities out of water, then simply passed in the microwave oven for a couple minutes, which simply evaporated the impurities, something that would definitely be useful in the future, as it could also probably be used in physical implants, as it is would be resistant to bodily fluids. Now, probably the most sought after property of CNT is its electrical properties. Carbon nanotubes, due to their arrangement and nanometric size, conduct electricity better than any known material at ambient temperature, and even outclasses silver, the most conductive element that was known thus far. Also, when below a given temperature, CNT becomes a superconductor, although at a much less lower temperature than other known superconductors like copper or magnets. The applications of CNT in the computer industry is thus becoming a reality, along with its application in that very field. Recently, the industrial giant IBM went and developed a prototype processor that was capable of achieving 2.8 GHz, putting it on par with Intel and AMD's middle-grade consumer processors, which run between 2.1 and 3.2 GHz. Although, it must be noted that the manufacturing process was only a semi-success, only being capable of achieving about 40% efficiency on oscillator manufacturing. That would be the transistors within a conventional processor. Which leaves IBM with a lot of room for improvement and maturing to do. Although in the next 5 years, we expect to see CNT-based processor units on the public market. Carbon nanotubes also have very promising thermal properties. CNT has a very high thermal conductivity, naturally, which gives them potential to operate in extremely hot environments without necessarily breaking down. The opposite is also true, since this property can be engineered differently by simply changing the geometry and structure of the nanotubes. For example, carbon in a nanofoam structure actually repel and dissipate heat easily instead of conducting it. Finally, carbon nanotubes at their very base, before they even become carbon nanotubes, have a manufacturing process that simply requires carbon as a raw material. And the process in itself is very environmentally friendly, since it uses mostly electricity. This means that we could certainly use atmospheric carbon dioxide pollution in order to manufacture them. Other sources like oil sand, coal mines, thermal generators, and etc. are also capable of producing the raw materials needed. CNT may also be very easily recycled, since there is only carbon as their component. To wrap things up, carbon nanotubes bring a bright future to our society. Their manufacturing process, applications, and uses being both eco-friendly and helping the development of more durable and reliable technologies opens up doors in the future to even more useful technologies, along with a greater understanding of the world that surrounds us, especially in the smaller world of what we call nanotechnology. Thinking about carbon nanotubes, what was yesterday's despisable carbon became the new wonder material of mankind. The sun is rising, and a bright future awaits us to forge it right at our doorstep. We'll live to see it, and that, I can guarantee it. It was your host, The2ksGamer. See you in the future.